Hello, this is Dr. Zebulon. Welcome to week 4 in the Intro to Physical Science class. It's my hope that these video tutorials have been helpful to some of you in understanding the expectation of the calculations. So very quickly, let's run through the assignment for this week. We are focusing on energy, and as shown here, we are looking at experiment 2 on the proper physics. You have the materials, the popper, the tape measure, and the stopwatch. Please pay very good attention to your measurements in this experiment. It is very important you make sure you have the right experiment, and because you're going to use those numbers to do the calculations. So very quickly, you are told to measure how high the popper goes in each time you pop it. Follow this procedure, put it on a hard surface and all that. So when you finish doing that, your tape measure, like I told you the last time, comes in inches and millimeters. So you must convert your numbers to meters to make sure you have the right number to solve with. If, for example, you put in a number like 90 in this space for the height, that 90 is most likely 90 inches. It can be 90 meters, because 90 meters, when you convert that to feet, is going to be way outside your house or the roof of your house. So make sure you do the conversion, and I showed you how to do that in the very first tutorial. And when you're taking the time measurement, please know that your time is when the popper goes up and down. That's the total time. So make sure you are very mindful of that. And for the calculations, you are using the average of these measurements. For the calculations, use the average of these measurements. And as expected, all calculations must be shown step by step in your answer book. So quickly, I'll jump to the answer book. So assuming I have done all my measurements and have my numbers, so I'm gonna put in the numbers here. I'll make up these numbers here. Take note that these are random numbers which I'm putting in as always, and it's going to be quite different from what you have. And I don't expect anybody to get these numbers in your experiment. So after I have my numbers, and assuming that my time goes with same time seconds, 15 seconds, 20 seconds, and 25 seconds. As expected, I'll come here to calculate the average. The average of 60 will be 60 over 3, which comes to become 20. And in this case, the average is 17.5. So once I have these measurements all done, then I come to the questions. Remember, the accuracy of your measurements will determine how these answers come out. So quickly, to calculate the potential energy, you have been given the formula m, g, and h, and you've been told in this equation that the m, which is the mass, is 0.01, the g is 9.8 meters per second squared. The height you will get from your measurement. So to calculate this particular question will be 0.01 times 9.8 times my height. Average of my height here is 20. Now look at the numbers I'm using here. Some of you were confused some time ago when we solved something with g. 9.8 meter per second squared doesn't mean that you have to square this number, just 9.8. If you multiply that out, so that will give you 0.01 times 9.8 times 20, and the answer will be in joules. That's the unit of energy. So my answer here is 1.96 joules. Uh, so that is what I expect to see for that number. And quickly you jump to number 2. In number 2, you've been told to calculate just the initial velocity VO. This is what we are calculating, VO. So in calculating this, we are supposed to break down this formula. But the good thing here is that the formula has already been broken down for you to know how to calculate just VO. So here it is giving note for question 2. Use the equation half times GT. So this is the equation you're supposed to be using. It's already been given there. So just to calculate this, all you need to do is to say the initial velocity, which is VO. So VO is equal to half times G, we know as 9.8, and T squared is the average time, which is 17.5 squared. So this is what you are asked to calculate here in the simplest form. So if we do this quickly, my answer will be half times 9.8 times 17.5 times 17.5, because we are squaring the 17.5. That will come out to be 1500. Now this is a very high number, so, and that is because we made up this measurements. So but it's important you know how to do these steps. Your time will be different, and I don't expect anybody's time to be up to this number. So 1500 meters per second is my velocity, initial velocity in this case. And that brings me to question 3. The question 3 here, you're supposed to calculate the kinetic energy. So we're supposed to use the initial velocity we calculated here to calculate the kinetic energy. So, and that's what you're told to do here. So for question number 3, you need to use a calculated velocity in question 2, which is rightly stated here. So let's do this quickly. So to calculate KE, please take note of this. KE is calculated by, and your book will have this, your KE is calculated by half mv squared. That's a formula for KE, mv squared. And based on this formula, we know that m has been given already up there as 0.01 kg, and we have our v as 1500 meters per second. So to calculate KE now becomes half times 0.01 times 1500. So if we multiply that out, 0.01 times 0.5 times, please make sure you take note of this correction. 1500 needs to be squared, so that'll be times 1500 again, and I'm getting a number which is also very high, 11250 joules. Now the reason why this number is this high is because these numbers are made up, they are not accurate measurements. So and each step is spelled out here, what you're supposed to do in the table. So take note of that. So that is my Ke, the kinetic energy. So the question 4 is now trying to compare based on what we know is the law of conservation of energy. The question is asking here to compare potential energy and kinetic energy. Are they the same or close to the same? Note, take note here that your potential energy and kinetic energy should be very close. If they are not, check to make sure your measured height in meters and your time in seconds. So if I did this experiment correctly, this number, the joule of the kinetic energy, and this number are supposed to be very close. So you have to watch out for that. If they are not, it means that something was done uh, incorrectly in the experiment. So, but this is just to show you how to get these numbers in calculation. And the final question says, is if energy stored in the popper rubber before it pops more or less than the energy the popper has at its total height? And you can explain that. For this question, I will also refer you to the law of conservation of energy. If you read that very well, you should be able to explain this question. Now, be mindful of just writing this. If you tell me law of conservation of energy, that is not an answer. I need to see a detailed explanation of your answer to this question before you can get full credit. And that, I believe, is all you're expected to do this week. If you have any questions, send me an email. Please, as I said in the class, don't call my cell phone and leave a voicemail on assignments, because that might not be a very effective for me to get back to you on the assignment. So send an email with your specific questions and I can respond to you in a timely manner. Thank you for listening and you have a lovely weekend.